Hi everyone. Today we're going to talk about digestion, and specifically I'm doing the Digestion 2 module. So let's get started. There's a lot to dig into. So first off, my topics are going to encompass the accessory organs. We're going to talk about the salivary glands along with the other mouth structures that aid in digestion. We're going to talk about the liver, and we're going to talk about how the liver makes bile and how that bile is stored. And then we're going to talk about the pancreas and all of the pancreatic juices that are made and how they are excreted into the duodenum by the pancreas. So let's get started. So first we're going to talk about the tooth. The structure above the gum line, all of that is the crown. The enamel is the hard outer covering. And then we have the dentin under that. We have our pulp cavity that's innervated by this these nerves and these blood vessels and veins. And they're coming through this root canal. So they have this root. This root is in the, if this a lower tooth, it's going to be in the mandible. And if it's a higher tooth, it's going to be in the maxilla. And this is just the general structure of our tooth. So our teeth are arranged. We have 32 adult teeth, but in this image, we only have 28 just because our wisdom teeth are missing. But in general, our incisors are here. There's four on the top and four on the bottom, and they're for cutting and biting food. So they're the teeth that your food comes in contact with first. And then we have our canines. They're more pointier, and they allow for that gripping and tearing of food, like tearing a piece of meat off a bone. Then we have our premolars. Our premolars are here. They're not as flat as our molars. They're not as sharp as our canines, and they're good for crushing in the beginning of grinding. And then our molars, they are the ones that grind and do our chewing. They're extremely important for like if you're eating a piece of celery or you have some carrots. So they're very important teeth, and some people will have teeth back here too. They'll have another one on each side on the lower and upper. Those are the wisdom teeth. But for teeth, but for me, I didn't have enough room, and my wisdom's teeth were taken out when I was younger. So the next slide is saliva. Saliva is another component of our mouth that aids in digestion. It contains enzymes that help to break down carbohydrates and fats. Salivary amylase is one of those. It's mostly made of water. It has so many properties. One of those properties is that it has antibodies and lysosomes that help to protect us from bacteria because we're constantly putting stuff in our mouth that has bacteria on it. And here is another aspect that is helpful with saliva. It moistens our lips and keeps them supple and our skin healthy there. And it also has a lot of epidermal growth factors that allow for quick repair when we burn our lip or we get a cut in our mouth or a scrape from our food. So, where is all that saliva stored? It's stored in our salivary glands. We have three right here. We have our parotid, it's under our ear. Our submandible gland, it's under our mandible. And we have our sublingual gland, and they all have these little ducts that come from them. So our parotid duct comes out, and it allows saliva to come out from our upper molar. Our submandibular gland has a duct that comes out from under our lower jaw. And then we have a duct here that comes out under our tongue. And this saliva, like I said, contains enzymes, and it contains other properties that are just very beneficial for our digestive health as well as just our mouth health in general. So here is the digestive aspect of that. So within our saliva, we'll have salivary lipase is going to help to break down fats, and we'll have salivary amylase is going to help to break down carbohydrates. And this is just a cute mnemonic that I've known for a while just in my own perspective of study, and I've always thought of it like this. So you can probably get it, so I'm not going to explain it yet. Well, I'll explain it right now. Anyways, the stomach contains specialized cells that work together. So the chief cells, they're going to release this pepsinogen, and then they in the inactive form is converted into pepsin. So pepsin begins the protein digestion, which is why the fire chief looking like a steak, holding a steak, and the Pepsi is a useful mnemonic because we can see chief cells release pepsinogen. Pepsinogen is activated by hydrochloric acid, and then it becomes pepsin, and then allows for the breakdown of that steak. So parietal cells, they release hydrochloric acid, which creates the acidic environment needed to activate pepsin. And they also release intrinsic factor for vitamin B12 absorption later in the ileum. The G cells, they release the gastrin, which stimulates gastric activity. And the endochromaffin cells, they release the histamine, which supports acid secretion. Mucus cells release protective mucus and bicarbonate so the stomach does not digest its own lining. So all of these cells are so important for the production of chyme and also for just the general health of the cell so that the cell stays healthy while the cells in the stomach stay healthy while they're releasing all of that acid. So this is just a general overview of the liver, just to give you a funny mnemonic that you can recall to help you understand later when you're actually thinking about liver anatomy, the anatomical true structure. So we have a huge right lobe, we have a little left lobe. In the middle, we have a caudate, stands for tail. That's what caudate means. And a curled tail is like a cat's tail. And then we have this square-like quadrant lobe, and then they're in this castle gate, which is called the porta hepatis, and that is the entryway that allows for the hepatic artery to bring oxygen-rich blood into the liver. And we have this hepatic portal vein, which is going to bring in nutrients-rich blood into the liver. And then we have the common hepatic duct that's going to send bile out of the liver. So now, after seeing that silly mnemonic, we can look at this and have a more orientation of what it is. The big right lobe, the little left lobe, the curly caudate tail, the caudate lobe. And we have this quadrant lobe, this square-like structure, the porta hepatis, that is the entryway. We have the proper hepatic artery, that's going to be our oxygen-rich nutrients. We have that portal vein, it's going to bring nutrient-rich blood into the GI tract. And then our common duct, which is going to be useful for sending out bile. So what is the unit of the liver? Why is it so important? Well, for one thing, it's these hexagonal liver lobules that are made up of these hepatocytes. These little square cells right here, these are hepatocytes, and they're in these little hexagonal lobules, and through them you'll find these little hepatic sinusoids. And these hepatic sinusoids, what they're doing, they're coming from these branches of the hepatic artery and the branch of the portal vein, and they're coming through this way and they're going out this central vein. And what they're for is they're exposing the liver to cells, like these liver cells, to nutrients, oxygen, and substances to detoxify. So they're taking all that stuff in and then they're using it. And another thing that they're doing with some of that stuff that they're took in is they're creating bile. And then the bile is leaving via these bile ducts, and it's going through this between the cell into these bile ducts via the bile caliculi. It's a really neat process. These hepatocyte cells are amazing. So from there, we're just going to talk about the hepatocyte for a minute. The hepatocyte is extremely important in so many functions within the liver. It makes up 80% of the liver. But for us, mainly what we are talking about specifically for digestion is the bile that it creates. So we see here we have bile. What is bile? Well, these are the components that make up bile. We have bile salt. That's what we're going to use for digestion. We have bilirubin, those broken down old red blood cells. And we have cholesterol. And these are some other components that make up bile: phospholipids, waters, and electrolytes. So why are these components important? Let's see. So why? Because they get stored in here and they get concentrated. And once they're concentrated, we're going to send them out here. So how do they get in here? So, like we talked about those hepatocyte cells, between them there's these little bile caliculi. The bile goes between there and it drains off into that bile duct branch. And then it will finally reach the left hepatic duct and the right hepatic duct. And it will come through the common hepatic duct, common bile duct. It will come into here. The common bile duct will go into there later. It'll come into here. And this gallbladder is like a little sac that it waits. And while it's stored, it's concentrated. And then when we need it, there will be a contraction that will allow from the OD sphincter, and it will come out the cystic sphincter. And that's extremely important because that allows us to store the bile until we need it and we've had a high fatty rich meal that we can use it. And how are we going to use that bile? So the way we're going to use that bile for digestion is we're going to use it with bile salts. So these bile salts right here, we have these fat just clumps together naturally because it wants to get away from the liquid because it's hydrophobic. So it does that by coming together so that gets as far away from the liquid as possible. And sometimes it will break up for a minute, but it'll come right together when they interact again. What this does, if when your body's moving and they break up, these bile salts get in between and it doesn't allow for them to form back together. And that creates smaller molecules that are happy. They're not trying to come back together because their hydrophobic ends are covered and they don't feel the need to come back together and they're smaller. That's going to increase the surface area. Once that surface area is increased, then you're in a situation to where those pancreatic enzymes, especially pancreatic lipase, can come in and start to break down those lipid molecules more easily. And then we can get a really good fat breakdown. So it's going to be good for absorption. So these are the functions of bile. We have emulsifies liquids we just talked about, and when those surface areas are increased, enzymes can get in there better to break down those fat molecules, so they're going to be absorbed more easily. This is one of the most interesting aspects about bile to me is that it can be recycled. It's recycled. It goes from the ileum to the hepatic portal vein, and then it goes right back from that hepatic sinusoid into those hepatocytes. The bile salt is reused again to make bile. And the things that also come in that we don't need that we send to the liver, like our red blood cells and our excess cholesterol, well, that kind of hitches a ride with the bile salts. And when it does that, it goes into the gallbladder and then it goes into the duodenum, then it's there ready to be excreted out with everything else. So I think that's a really good, very neat way that our body is set up. So let's talk about the pancreas. So the pancreas, the anatomy of the pancreas is we have the common bile duct that we just saw when we were looking at the liver and the gallbladder. We have this C-shaped structure, that's the duodenum. That kind of is where the pancreas sits. And this pancreatic duct, that's where all those enzymes are going to come in at. And it's the ones from the exocrine. So these acinar cells, they're going to produce pancreatic juices full of enzymes and bicarbonate that's going to allow for the breakdown of the chyme further in this duodenum-like region. So let's see what we can see about exocrine and endocrine. So this is our pancreas, this is the exocrine function, and this is the endocrine function. So our exocrine function we just talked about. So what's going to happen is, the reason I have this pancreas lounging around here because I'm trying to help you to remember that parasympathetic nervous system, the vagal input is what stimulates this pancreas. But it's not really lazy because when you think about it, when chyme comes into the duodenum and the duodenum secretes secretin, well, The duodenum needs some help. It's in a very acidic situation and wants to get out of it. So the pancreas has got to get off that lounge chair and start working hard. It's got to start secreting bile carbonate-rich fluid, but it's also got to start secreting pancreatic juices to help break down that food. And so that's the exocrine side of it. And on the endocrine side of it, within these cells, we also have, within the little pancreatic tissue, we also have these endocrine cells, which emit hormones into the blood system. It's the islets of Langerhans, and secrete insulin and glucagon into the bloodstream. And the reason this is important is because it's going to regulate our blood levels. So that is an extremely important method of how the pancreas works within digestion. So as far as the exocrine side of it and the pancreatic enzymes that are released into the duodenum, we have pancreatic amylase, which is going to break down carbs. We have pancreatic lipase, which is going to break down fats. We've already saw these characters before in saliva, but now these are pancreatic enzymes. Then we have pancreatic nuclease. It's going to be secreted actively, and it's going to break down our ribonucleic acids and our deoxyribonucleic acids. But some of the pancreas enzymes they're sleeping. And the reason they are is because they break down proteins. So they'll go into the duodenum, then they will be activated. And once they're activated in the duodenum through a series of events, they can break down proteins. And this is also an amazing map for how digestion works, because you don't end up breaking down proteins where they don't need to be broken down, especially your own body proteins. So that is an extremely neat way to do things. The next thing is our hormonal regulation in the small intestine. So the duodenum is going to send out signals via hormones. So we have our cholecystokinin, which is going to, when the duodenum receives chyme, it's going to send out these stretch receptors, and it's going to emit cholecystokinin to the pancreas as well as the gallbladder, and it's going to stimulate the release of bile from the gallbladder and pancreatic enzymes from the pancreas. And they're going to come into the duodenum, and they're going to help the duodenum to break down those molecules for nutrient-rich substance to be absorbed later. And it's also going to tell the stomach that it needs to slow down, especially if there's a ton of food coming. It's going to think, well, I can't deal with all this food right now, all of this chyme, so I need to slow down the stomach's emptying into the duodenum. So the gastric inhibitory peptide, that will help to slow that down. So how does this all work? There's 3 phases, and it's all ran by the enteric nervous system. So the cephalic phase is very important because that's the phase that starts everything before food even enters the body. So with our senses, we get ready to eat, and our body gets ready to also. We start to emit juices, motility starts, and it's all controlled by the secretions that are innervated via the submucosal Meissner plexus and the muscles that contract via the myenteric Arsbach plexus and the longitudinal muscle layer. So this is the cephalic phase, and then we have the gastric phase. The gastric phase is going to start when the stretch receptors are stretched within our stomach. So we've had a big meal, it's gotten down to our stomach, and our body senses that we have eaten something. And these myenteric plexus starts the motility, and these submucosal plexus starts the secretion. And that allows us to start turning the food and breaking it down so that it can be sent to the duodenum and it can be further digestion. So this is what we just talked about. This is the intestinal phase. So we talked about the gallbladder, its role, and the pancreatic role in releasing enzymes into the duodenum via this KKC. And we talked about the gastric inhibitory peptide, how it tells the body to slow down a little bit because it's getting too much chyme too quickly into the duodenum. And we talked about secretin, how it will tell the pancreas that it's in an acidic environment and that it needs to secrete a little bicarbonate. All of these things work together so wonderfully. So that's basically digestion. First, we ingest, it goes into the stomach, and then once in the stomach, we get mechanical and chemical digestion, and from there on, it goes into the duodenum. From the small intestines, it's absorbed into the large intestines, it's defecated. I hope you enjoyed this. This is my citations. Have a wonderful day.